Hi, in this question, it is said that a galvanometer with a coil of resistance 100 ohm, that is the galvanometer resistance, okay, we will write it as G, which is given 100 ohm, right? And scale having 100 division has a current sensitivity of 25 microampere per division. So the current sensitivity is given, current sensitivity of this galvanometer is given 25 microampere per division, okay? And the galvanometer resistance is given 100 ohm. It has 100 divisions, so the number of division is 100. This is the number of divisions. Clear? So now the question is, how will you convert it into an ammeter of range 0 to 5 ampere? So the ammeter range is 0 to 5 ampere. That means we can measure the current up to 5 ampere with this ammeter. So the question is, there is a galvanometer having resistance 100 ohm. The galvanometer has 100 division, that is the total number of division. The current sensitivity in the galvanometer is 25 microampere per division, right? And the ammeter range is 0 to 5 ampere. That means the maximum current that can be measured through this ammeter, that will be 5 ampere. So now how we can convert this galvanometer into this ammeter? Okay. So for that, first we have to convert the galvanometer into ammeter. So now we have to connect a small resistance or shunt in parallel with galvanometer. In parallel with galvanometer. Okay. As we know that with ammeter we can measure the magnitude of current, right? So the resistance should be small. So if the resistance of any electric circuit is small, then only we can get the exact reading of the current, right? So that's why the shunt will be connected in parallel with galvanometer, and shunt is a very small resistance, and we know that if we connect two resistances in parallel, the effective or the equivalent resistance will be small. Suppose this is the galvanometer, right? And with this galvanometer, we have to connect a small resistance that is known as shunt in parallel. Okay? Like this, we have to connect. Okay? Suppose this is high potential A point and this is low potential B point. Now the current will enter. See, I is the source current. So the source current will get divided into two parts. One part will go to the galvanometer as Ig. So Ig is the current through galvanometer, and suppose this is shunt. So the another part, that is Is, will enter the shunt, right? So we can say Ig plus Is is equal to the total current I, the source current, or we can also say the shunt current is equal to I minus Ig. Okay, now we have to find out the value of shunt, because see, the galvanometer resistance is given, the current sensitivity is given, that means Ig is also given, but we have to find out Ig. How to find out Ig? See, Ig is equal to the current sensitivity is given 25 microampere, that means 10 to the power minus 6, right, per division. So into 100 division, that will be the total current through the galvanometer. Okay, part division, the current is 25 into 10 to the power minus 6. So through 100 division, the current will be 25 into 10 to the power minus. So it will be 25 into 10 to the power minus 4 ampere. So this is the current through the galvanometer. Okay. Now see, the total current will be I, we know, and what will be the ammeter range? That is 0 to 5 ampere. So the source current or the total current should be 5 ampere, right? So it will be 5. And what about Ig? We got 25 into 10 to the power minus 4. So from here we can find out Is easily. Okay, so Is is equal to 5 minus 25 into 10 to the power minus 4 ampere. Okay, so now we got the current, right? Now see, when the two resistances are connected in parallel connection, we know the potential difference should be same because they are connected in between two common terminals, that is A and B. So the potential difference will be same for G and S, right? So we can say the current Ig into G must be equal to Is into Sy, because this is the potential difference between two terminal, that is Va minus Vb or delta V. The potential difference should be same. They are connected in parallel combination. So current into resistance, right? So from this we can get S. S is equal to Ig into G by Is. Okay. So what about Ig? See, Ig we got 25 into 10 to the power minus 4 and G is 100 and Is 5 minus 25 into 10 to the power minus 4. Okay. So the answer will be, so 5 minus 25 into 10 to the power minus 4, it's coming 4.9975 equal to 0.0500 ohm. Okay, because shunt is a small resistance, 0.0500 ohm. So this is the required shunt which can be connected in parallel to the galvanometer so that an ammeter of range 0 to 5 ampere can be formed. Okay, so this is the concept of this numerical, and the answer will be 0.0500 ohm, the value of shunt. Okay, so I hope you understand the concept and the solution. Thank you. All the best.